Hey, what's going on, guys? Mr. Flores here, and this is a video that is going to be dealing with solving a system of equations using substitution. Okay, now substitution. I mean, I like the method. It's pretty easy. I think all the system of equations are kind of easy. But so basically, when we talk about substitution, it really is exactly what we're talking about. Okay, and I'm going to come back to this problem here. But what I want to do is I want to first talk about what do you mean to like substitute something in. Okay, so say we have a problem where we know that y is equal to 2 plus x. Okay, and we also know that x equals 3. All right. Well, ultimately, we want to know what is x equal and what does y equal. So really the whole process of substitution is simply replacing a variable in one equation for what we know it equals. And what I mean by that is these two equations here are in a system. So that way we know they have a certain relationship. And we know that x is equal to 3 for this set of equations, this system of equations. Well, if x is 3, that means that in the y equals 2 plus x, this x is also equal to 3. Okay, which is nice because we can just substitute, hence the substitution, the 3 in for x. So now it becomes y equals 2 plus 3, or that y is equal to 5, giving us an answer of x is 3, y is 5. Okay, in a nutshell, that is all that substitution is. We're going to do some trickier things, and we're going to do a word problem or two, but when it boils down to it, that's all substitution is. All right, but which leads me back to this problem here, where we have 3x plus 6y equals 12. All right, on your guided notes, there's two problems here. This is one of them. All right, and basically what we want to do is, for substitution, you need to get a variable all by itself. Well, if we notice here, this is in standard form. All right, so neither x or y is solved for. Neither of them is alone. So ultimately what we want to do is we want to use algebra and manipulate this equation so we can get x or y all by itself. All right, I'm going to get y all by itself, so I'm just going to put a box around y. All right, so if we look here, the first thing we must get rid of is the 3x. Since it's a positive 3x, we can subtract 3x from both sides. All right, which is going to leave us with a 6y on the left side is equal to the 12 and negative 3x. We can't combine because it's a 12 and, well, the negative 3 has an x with it, so we can't, they're not like terms. All right, and lastly, again, we just want to get this y all by itself, so we have to divide both sides by 6. Make sure when you divide the right side by 6, you divide every piece by 6, or every term, I should say. So then these are going to cancel, so you get y equals 12 divided by 6 is 2, minus 3 divided by 6, for all you fraction lovers, it's 1/2, x. All right, so we know that these two equations are exactly the same. Okay, they're equal, except what we did was we just solved for y. Now we could use this in a problem or a system of equations to substitute y for another equation. All right, but again, that's the process of changing around an equation to work for you. Okay, you're going to need to be able to do this for some of the problems. So if you have questions on this, make sure you stop the video and ask. All right, also pause the video right now and I would do the other problem just so you can make sure you know what you're supposed to get. All right, so when you know that second problem right next to this, unpause the video and let's move on. All right, so again, we're going to come back to this problem that we did in the last lesson. It was using our friend Sarah and our friend John. Okay, and Sarah and John were at a supermarket. At the beginning of the week, Sarah has $1, John has $3. Every day, Sarah makes $1 and John makes 50 cents. Create two equations, model the situation. Then we're going to use substitution to solve it. Right? Well, if we remember from when we created equations back in the beginning of the year, we really focused on the two types of equations we really use in algebra, at least for now. We can create equations when it gives us a starting value and a rate of change, or sometimes they give us two rates of change and a total value. All right? If you notice, this says that Sarah, at the beginning of the week, Sarah had $1, aka that's her beginning value. Okay, so her begin, oh, that's not how you spell begin. Her begin is $1. Okay, and then it says that every day she makes $1, so her change is $1 a day. I'm going to pause this real quick to fix my pen. All right, I'm back. So, Sarah begins with $1, and her change is $1 a day. Now we're going to go to John. His beginning is $3. So John begins at $3. Okay, and his change is going to be 50 cents a day. All right, and if you remember from last video, this is the same problem that we used to graph, and we solved this graphically, and same equations, nothing's changing. I just want us to be able to look at how we can use substitution, elimination, or even graphing to solve the same system. And you always get the same answer, and that's because mathematically we're not doing anything differently. The process is just different. All right, so we know that in y equals mx plus b, all right, the beginning is always going to be your b value, and the change is your slope. So we know that she gets her equation to become y equals x plus 1, okay, because she begins with $1 and her slope is a 1x or a 1, which you don't write. All right, and then I'm actually going to move this to the middle just so it looks more like a normal problem. All right, so if you look at the top equation, that's going to be Sarah. All right, and then John, I'm going to write his equation right under it. We know that John is y equals, he makes 50 cents a day, so it has to be 1/2 x. And then he's starting at $3, so he's at y equals 1/2 x plus 3. All right, so these are our two equations. And basically the word problem aspect is almost over because now it just looks like a regular problem that we have. All right, the nice thing here is that we know that y equals x plus 1. We also know that y equals 1/2 x plus 3. So since we can use substitution, and we know that these two equations are in the same system, we can take this x plus 1 and substitute it into the second equation for y. Okay, because we know that y is equal to the same thing, right? So instead of it being y equals 1/2 x plus 3, we can do x plus 1, since y equals it, and set that equal to 1/2 x plus 3. All right. And what we're going to do now is we are going to have to solve this equation for x. So what I'm going to do is I'm going to move this 1/2 x to the left, the 1 to the right. So I'm going to subtract 1 from both sides. Subtract 1/2 x from both sides. All right, and again, if you have to do this in 2 steps, that's fine. So that cancels, that cancels. X minus 1/2 x leaves us with 1/2 x. Okay. 3 minus 1 leaves us with a 2. All right, so now we know that 1/2 x is equal to 2. Again, if we want to get x alone, we're going to multiply both sides by a 2, since 2 and 1/2 are reciprocals, and they're going to cancel. All right, then we know that x is going to equal 4. Okay, because, well, 2 times 2 is 4, and x equals 4. So we're done almost, because we just know that x equals 4. But again, with the system, we want to know the solution for x and y. All right? But the nice thing here is that we know that y is equal to x plus 1, or we know that y is equal to 1/2 x plus 3. The cool thing here, and this is why I love math, because there's so many cool little coincidences that we stumble upon. Okay, this goes back to the idea of a system of equations in that y is equal to the same exact thing. Okay, so if we want to find out what is y equal when we know x is equal to 4, we want to substitute again, hence the substitution. We want to substitute the 4 into either equation for x. Okay, so it's going to become 1/2 times 4 plus 3 is equal to 1/2 times 4 is 2 plus 3, which gives us a grand total of 5. Okay, so in order to find out what y was equal to, I found out that x was 4, and I just substituted this into one of the equations. All right, some of you guys might not believe me because you still think this is probably like voodoo magic. So I'm going to show you that if we take 4 and substitute it into the other equation for x, y comes out to the same thing. Because in both these equations, since it's a system, the y and x must be the same. Okay, so it's going to be 4 plus 1 is equal to 5. And ooh, look at that. No matter which equation I substituted the 4 into for x, we got 5 as our y. Okay, and again, that's not a coincidence. That's how systems work. Okay, and that's why it doesn't matter which equation I put the 4 into, you get the same answer. All right, you don't have to plug it into both from now on. I just wanted to show you why it works. Okay, so our answer is 4 comma 5. But we know that this is a word problem, so we can't give me a coordinate, or you can't give me a coordinate. You must tell me that at 4 days they had, my pen's being all weird, they had $5 each. All right, let's use our English. Let's turn this math to English, which is something cool. But anyways, that's regardless. But anyways, so our solution to this is 4 comma 5, which translates to 4 days they had $5 each. Okay, and that is solving a system of equations using substitution. If you have your notes from the last class, you know that this was the same answer we got when we solved it graphically, of 4 comma 5, or 4 days and $5 each. All right, so now we're just going to go to an arbitrary problem and just do some good math. So we have here that y equals negative 1/2 x plus 5. We know that 2x plus 4y equals negative 4. Okay. Again, this is nice because in order to substitute, you have to get a variable all by itself. Well, if you look at our first equation, the y is all alone. So we know that we can take this negative 1/2 x plus 5 and substitute into this y. Okay. So the second equation is actually going to become 2x plus. All right. Now this is where it gets tricky because in the second equation it's 4 times y. Okay, so 4 times the variable y. Really what we're doing is we're replacing this y with negative 1/2 x plus 5. Since we're just replacing or substituting into y this whole quantity, we must multiply 4 times this whole thing, which means we must put it in parentheses. Okay, so it becomes negative 1/2 x plus 5, close parenthesis, equals negative 4. So the second equation evolves into 2x plus 4 times negative 1/2 x plus 5, because that's what we substituted in for y. And it's still equal to negative 4. All right. So now if you notice, we only have x's in this equation, so we're going to simplify. We know we have to distribute this 4. So we're going to get 2x minus 2x plus 20 equals negative 4. Okay. And then we're going to simplify. The positive 2x and the negative 2x cancel. Okay, and we get 20 equals negative 4. All right, and if you read the little disclaimer, the little instructions above this problem, it said that this is one of those special cases, okay? Because we know with systems, we can get one solution, no solutions, or we can get infinite solutions. Now, what we want to look at here is, does 20 equal negative 4? Well, the answer is no. 20 is never going to equal negative 4. So right when you start simplifying your equations, you get something that's never going to work, you automatically know it's going to be no solution. Okay. I threw this one in there just to kind of keep you on your toes, and that hopefully you're reading the directions and you knew that something weird was going to happen because I told you in the directions something weird was going to happen. But if you ever get a problem where it starts boiling down and you get something that's not true, your answer is no solution. Okay, or null set. The other way, the other type of answer we can get is infinite solutions. And we know this because, well, we covered all these bases before. So this shouldn't be anything new. The only thing that's new is the algebraic part. So infinite solutions, okay, that would happen if you boil down an equation. Okay, you do all this work. Boom, 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 this is work. And we get something that says 3 equals 3, right? This is a true statement. 3 is always going to equal 3. If that ever happens, all your variables cancel and you're left with something that's a true statement, your answer is infinite solutions, okay? Because it's true. So if you do all your work and it boils down to something that's not true, okay, your variables cancel and you get 20 equals negative 4, that would be no solution, okay? And if you get everything that boils down and you get the same thing on both sides, that's infinite solutions, okay? And that's good. That you get either of those, all right, it's just a tricky spot. So that was this problem, and this is why read the directions, you know this would happen. Alright, so no tricks here. This is a good problem. We have 6x plus 2y equals 4, y equals 2x minus 3. I'm going to have to turn the page to get this one. Alright, but this one's nicely set up for us because the second equation is already y equals something. So we know that since it's y equals, okay, 2x minus 3, we can substitute 2x minus 3 into the first equation. So, which is nice, because it just makes our life easier. So the first equation, or the top equation, becomes 6x plus 2. Right? Again, we're multiplying 2 times y. So when we substitute 2x minus 3 in for y, we must still multiply 2 times the whole thing. So it's going to be 2x minus 3 in parentheses equals 4. All right, so now we just got to solve for x. So distribute the 2, and you're going to get 6x plus 4x minus 6 equals 4. All right, we can combine like terms, so we get 10x. Ooh, sorry, I don't want to do that. I'll do it in red. I mean blue. So I get 10x minus 6 equals 4, and hopefully you see that this is going to come out nicely. All right, we want to get this negative 6 to both sides, so we do the opposite of subtraction and add it. All right, and we get 10x equals 10. Divide both sides by 10, and we find out that our answer is, well, half of our answer is x equals 1, which is cool because, well, that makes our life easy because 1's an easy number to work with. All right, so what we got to do is, now that we know x is equal to 1, we can go back to either of our original equations, substitute, okay, there's a lot of substitution going on, hence the name substitution. We're going to substitute 1 in for x, okay? I'm going to pick the bottom equation since y is all by itself, but it doesn't matter. You could substitute in for here or down here. You get the same thing. All right, so when we substitute 1 in for x, it's going to become 2 times 1 minus 3 equals 2 minus 3, which is equal to a negative 1. Okay, so we know that y equals negative 1. So our answer, when we do this, we're going to write it as a coordinate. Always write your answer as a coordinate unless it's a word problem. We know that x is equal to a positive 1, y is equal to a negative 1, and that's all she wrote. All right, and that's the problem. If you can tackle this problem, you basically have a good understanding of the idea behind substitution, because it doesn't get any harder than this. Sometimes we have to manipulate our equations, which we did in that first problem where we solved for y, and we're going to do it in the next one. All right, but basically this is what substitution boils down to. All right, so lastly, this is another problem that you have in your packet. So you have x minus y equals 2, and 4x minus y equals negative 1. All right. So if we notice here, both of these equations are in standard form. Now, normally if they're in standard form, I would use elimination. We don't know how to use elimination, so we can't right now. We still have to use substitution. And like I said in the beginning, with substitution, we need to get a variable all alone. We need to isolate x or isolate y on one of these sides of the equation. Okay. Doesn't matter which equation we use, you'll still get the same thing as long as you do it right. So if we look here, what I'm going to do is I'm going to take x plus y, or x minus y equals 2, and I'm going to add y to both sides. Okay. So I'm going to rewrite it underneath here. So x, the y canceled, so we have x equals 2 plus y. Right? Now, this is nice because we know that we have 4x minus y equals negative 1, x equals 2 plus y, x is all alone, so we can substitute 2 plus y for x in the first equation. All right, see the trick? This is a little harder of a problem because we had to manipulate. But again, once you get a variable alone, you just substitute whatever it equals in for the variable. So it's going to become 4 times 2 plus y minus y equals negative 1. All right, now he's going to get y by itself. So we're going to distribute the 2, or the 4, I mean. We're going to get 8 plus 4y minus y equals negative 1. We're going to combine like terms, and you're going to get 8 plus 3y is equal to a negative 1. Okay, I'm going to, hopefully you guessed it, subtract 8. Okay, these cancel. You get 3y is equal to negative 9. Okay, lastly, we want to get the y all by itself, so I'm going to divide by 3, and I'm going to write our answer up here, just so it's a little easier for now. So we know that negative 9 divided by 3 is y equals negative 3. Okay, which is cool. We know what y equals, but we still have to find out what x equals. And the nice thing about using substitution or using any of these equations, okay, we really have 3 equations we can work with. Okay, we could do x minus y equals 2, plug negative 3 in. 4x minus y equals negative 1, plug negative 3 in. Or we could say x is equal to 2 plus y, plug negative 3 in. Okay, because these 2 equations right here are exactly the same because of how we manipulated them in the beginning. So these are the same. Okay, what I'm going to do is I'm going to take the negative 3 and substitute it into this equation since it'll make my life the easiest. Okay, so it's going to become 2 minus 3, which is 2 minus 3 is negative 1. So we know that x equals negative 1, giving us a grand total answer of negative 1 comma negative 3. All right, and I think that's it. Yeah. So hopefully substitution's a type of problem that you guys understand how to do, because it is rather straightforward. Okay, as long as you have your variables solved for. Okay, you plug and chug and you do a lot of algebra, which is really cool. It's really fun. But again, word problems are not scary as long as you remember the 2 types that we're really going to be given. Other than that, if you have questions, let me know. In this packet, there's a whole bunch of word problems to work on. There's a whole bunch of practice problems to work on. The answer's there for the practice problems. Okay. If you have questions, let me know. Make sure you know this stuff, because, well, you're going to have to know. So, again, if you have any questions, let me know. Hopefully you understood the video, and have a